learned that convection in the mantle creates high mountains and deep trenches at subduction zones. Here's another way of looking at convection in the mantle. It creates high places and low places on the surface of the Earth. Remember, convection in the mantle creates high places and low places. Other forces break down the high places and fill in the low places. These are weathering forces. They break down high places. They work with carriers and gravity to transport material that is broken down, and they drop this material to fill in low places. The weathering process and the process of convection take place at the same time. So while mantle convection is creating larger differences, high places and low places, the weathering forces are trying to make things level again. Weathering forces break down high places. They do this by loosening chunks of rock and by breaking bigger rocks into smaller rocks. The weathering forces include chemical action, the action of water, the action of temperature change, and the action of ice. Chemical action may dissolve rock that is in a high place. If acid comes in contact with this rock, the rock dissolves. This is what happens to some rocks over a long period of time. The action of water may create great forces that break rocks loose. At beaches and along shorelines, the action of water breaks large rocks down into smaller and smaller rocks until they look like this. Here, the action of water is constantly cutting these cliffs. In time, parts will break off and fall into the river. The action of temperature change is also important. Changes in temperature may crack rocks. The rocks expand when heated and contract when cooled. This happens again and again until they break apart. Ice weathers rock by creating great pressure. Here, water settles into a crack. Water is unusual. When it freezes, it expands, so ice can break rocks loose like this. Here, the pressure of a moving mass of ice and snow, called a glacier, splits rocks. Remember, the weathering forces break down high places by loosening chunks and breaking bigger rocks into smaller rocks. The weathering forces are chemical action, water, temperature change, and ice. After the weathering forces break down material, gravity goes to work and transports the material that is broken down. Remember, gravity is a force that pulls things toward the center of the Earth. Gravity can work alone. When rocks from high places break loose, gravity transports them to lower places. When gravity works alone, we have landslides or rock slides. Gravity also works with carriers. The major carriers are water currents, glaciers, and wind. These carriers may also break down the materials as they are transported. Here's a stream. It has strong water currents. The sand and stones are being moved by this stream and are constantly being rubbed and scraped. As rocks with sharp edges are carried by the stream, the sharp edges are scraped and sanded until they look smooth like this. Here's a rule about streams. The faster streams move, the larger the rocks they can carry. Up here, the stream moves very fast and is able to carry large rocks. After the stream leaves the mountain, it starts to slow. It can no longer carry the larger rocks, just the smaller ones. So the larger rocks are deposited here. The stream slows even more and deposits smaller rocks here. Tiny bits are carried all the way down here. Glaciers also transport material from higher places to lower places. They carry large boulders, and with tons of pressure, they scour and scrape the surface of the land below them. When glaciers melt, they deposit all the material they picked up, everything from huge boulders to tiny bits. So glaciers are different from streams. Glaciers deposit everything at the same place, while streams separate rocks by size. Wind is an important carrier that transports material to low places, and wind works just like water. The faster the wind moves, the larger the pieces that it can carry. Slower winds can carry smaller bits of material, but not the larger ones. In places that are dry, we see this pattern. The middle of the area is rock. The wind blows all loose material from this area. Around the edges, there are sand dunes. These are the largest bits of loose material that have been transported by the wind. If we go out farther, we find much smaller bits. Remember, weathering forces break down the high places. Gravity and the carriers, water currents, glaciers, and wind, transport the material to the low places. When gravity and the carriers drop the material they are carrying, they fill in low places. The materials deposited in low places are called sediments. Sediments form in flat layers. That's an important rule. 3 important sediments are sand, mud, and lime. Sand is rock that is broken down by weathering forces and moved by carriers. Large deposits of sand are found at many beaches. Mud is rock that is broken down by weathering forces into much smaller grains. Mud grains are sometimes 100 times smaller than sand grains. Here's the typical pattern of sand and mud deposited where a river empties into the ocean. The larger grain material, sand, is here on the shore near the beach. Farther out is smaller grain material, mud. Remember, water currents can carry smaller grains farther. So the mud is out here and the sand is closer to the shore. A third important sediment is lime. The lime that we refer to is a chalky white substance. Its official name is calcium carbonate. These seashells are made of calcium carbonate, or lime. When shelled organisms die, their shells settle to the bottom of the sea and form flat layers. Some of the lime sediments in the ocean are carried from the land. Here's a stream that runs through beds of limestone. These rocks are made of lime, or calcium carbonate. Some of that lime dissolves into the water. When the stream empties into the ocean, some of the lime it carries may settle to the bottom. Here's a beach. What kind of sediment is going to be deposited at the beach? Yes, sand. Over time, the crust moves from convection in the mantle. The beach is no longer a beach. The sand is now in deeper water. What kind of rock sediment will be deposited on top of the sand? Yes, mud. Now let's say that more crust movement occurs. The ocean floor is pushed down even farther below the continent, and there are a lot of sea organisms that live here. What kind of sediment will be deposited now? Yes, lime. Remember, over time, mantle convection changes the ocean floor. That means an area that had been a beach may become the floor in a deeper part of the ocean. With each change, different sediments are deposited on top of each other in layers, always flat layers. Once more, what do we call the material that is deposited in low places? Sediments. What are the 3 main types of sediments? Sand, mud, and lime. And these sediments always form in what kind of layers? Flat layers.